In our quest to search for extraterrestrial life, we face two possible outcomes. Either we successfully find and communicate with another civilization, or we encounter continued silence. Regardless of the outcome, this journey offers significant insights into our place in the universe, challenging the notion that we are alone. Currently, our exploration has identified thousands of exoplanets, and with cutting-edge observatories like the James Webb Space Telescope and projects like starshade on the horizon, this number is expected to rise significantly. These advanced tools will help us analyze exoplanets more effectively and assess their potential habitability. However, merely finding a planet with promising conditions does not guarantee the presence of life. Life might never have arisen on that world, or it could have been wiped out by catastrophic events like impacts or supernova explosions. Planets showing potential habitability and containing essential conditions for life become prime subjects for study. Specific organic compounds, such as chlorophyll, predominantly produced by living organisms, could serve as key indicators. Additionally, signs of substantial biomass, akin to rainforests on Earth, could create discernible changes in environmental parameters, distinguishing them from barren landscapes. In our search, we should remain open to encountering various forms of intelligence and evolution. The timeline of life on Earth spans billions of years, from microbial life to technologically advanced civilizations. Considering the vastness of the universe and diverse planetary conditions, we may discover life at different stages of development, some akin to ancient microbial life, and others resembling technologically advanced societies. Our understanding of intelligence, civilization, and communication is rooted in our own experiences and norms. However, projecting our behaviors onto potential alien life forms may lead us astray. Alien civilizations might possess vastly different cognitive abilities, values, and communication methods. Their understanding of the universe, science, and technology could differ significantly from ours, resulting in unconventional approaches to space exploration and communication. While we seek extraterrestrial intelligence through radio signals and technology, advanced alien beings may have developed alternative, incomprehensible forms of communication. Furthermore, the concept of intelligence itself may vary among different species. On Earth, intelligence manifests diversely, from human cognitive abilities to complex social structures in certain animal species. Alien intelligence could encompass a wide array of forms, making recognition and comprehension challenging. The Fermi paradox assumes that advanced alien civilizations share our expansionist tendencies, but this assumption could be overly anthropocentric. Extraterrestrial civilizations may have entirely different motives and goals, diverging from our historical exploration and colonization drives. Contemplate the notion that certain advanced extraterrestrial societies prioritize environmental harmony and opt for the preservation of their home planets over colonization. They may have achieved sustainable equilibrium and prefer to remain concealed to avoid potential interstellar conflicts, offering an alternative resolution to the Fermi paradox. This encourages us to expand our perspectives and remain modest when faced with the unknown, recognizing the vast array of possible alien behaviors within the cosmic landscape. Scientists examining human civilizations and large urban centers have identified recurrent patterns of growth followed by eventual decline. Similarly, they propose two scenarios for extraterrestrial civilizations. In the first scenario, a civilization becomes aware of the perils of rapid expansion and chooses to halt its interstellar ventures, refraining from further colonization. In the second scenario, a civilization fails to grasp the consequences of its expansion, resulting in ultimate collapse due to unsustainable growth. Both scenarios, from our viewpoint, yield the same outcome: no visitation or evidence of their existence, owing to the immense distances that hinder meaningful contact or detection. This hypothesis, termed superlinear scaling, suggests that civilizations may reach a juncture where sustaining their colossal energy requirements for colonization becomes insurmountable unless they act promptly to address these challenges. Interestingly, If these civilizations were closer to us, their energy emissions might render their presence conspicuous, especially if they were nearing collapse. This hypothesis aligns with other suppositions in the quest for alien life, including the prioritization of exploring developed, intelligent worlds as opposed to nascent, primitive ones. Taking our earthly perspective into account, radio signals emitted over the past century constitute some of the most detectable indicators of our intelligence. Nevertheless, these signals would blend into background noise after traversing roughly a light year, limiting their detectability to a relatively small portion of the expansive Milky Way. Taking this perspective into consideration, the proposed solution suggests that even among the numerous star systems that could have received our signals, there's a substantial likelihood that they wouldn't have been able to detect our unintentional transmissions. Furthermore, if non-intelligent life is prevalent in the galaxy, advanced civilizations may not see a reason to allocate resources for contacting potentially non-intelligent worlds. Therefore, the absence of communication from extraterrestrial civilizations could be attributed to their lack of evidence of intelligent life on Earth. The vastness of the galaxy and the challenges associated with detecting intelligent civilizations from afar make it plausible that advanced alien beings have not yet detected any indication of our intelligence. The rare Earth hypothesis proposed by Peter Ward and Ron Brownlee posits that the unique combination of geological and environmental conditions on Earth makes the evolution of complex and intelligent life exceedingly rare in the universe. They argue that while microbial life might emerge on some planets, the development of sophisticated life forms is highly unlikely. In contrast, the cosmic zoo hypothesis, proposed by William Baines and colleagues, suggests that just as there are various styles of music, there are multiple pathways for life to evolve from simple microbes to complex macroscopic creatures similar to animals and plants. This hypothesis implies that once life arises on a planet, it has the potential to evolve into diverse and substantial forms, provided the planet remains habitable for a sufficient duration. In this ongoing debate, two critical caveats must be acknowledged. Firstly, the origin of life on Earth, though not considered a unique event, remains shrouded in mystery, leaving room for the possibility that Earth's conditions are indeed rare. Secondly, the evolution of technologically advanced life, exemplified by humans on Earth, appears to have occurred only once, making it challenging to estimate the prevalence of such advanced civilizations on other worlds. To ascertain which hypothesis holds true, scientists are turning their attention to our own solar system, with various planets and moons including Mars, Europa, Enceladus, Titan, and Venus, providing opportunities to search for microbial life. The discovery of independently originated microbes in these locations would imply that life is widespread in the cosmos, serving as a significant data point. However, to differentiate between the rare Earth and cosmic zoo hypotheses, the quest for complex macroscopic life necessitates exploration beyond our solar system, particularly focusing on exoplanets orbiting stars other than our Sun. In 1961, American astronomer Frank Drake formulated a simple equation to estimate the number of intelligent civilizations in our galaxy. Using rough approximations, Drake calculated a range from a minimum of 1,000 to as many as 100 million extraterrestrial civilizations in the Milky Way alone. However, these numbers remain highly disputed, as various factors, such as planetary configurations, atmospheric conditions, and celestial stability, may influence the emergence of intelligent life. With a sample size limited to Earth, it remains nearly impossible to definitively determine whether life is rare or common in the universe. In a paper titled "Eternal Inflation and Its Implications," theoretical physicist Alan Guth used the concept of cosmic inflation to argue that, assuming the existence of an infinite number of universes, each universe likely hosts only one advanced civilization. According to Guth, cosmic inflation generates an infinite number of pocket universes at an extraordinary rate, with new universes appearing every second, far outnumbering older universes. Therefore, Guth suggests that the prevalence of advanced civilizations may be quite rare, given the vastness of cosmic inflation and the immense number of newly formed universes. In simpler terms, consider this intriguing perspective. Picture the universe as an expansive and diverse art gallery filled with countless unique paintings, each representing a distinct world with its own story and inhabitants. These paintings continuously emerge, like magic, with each passing moment. However, most of these new paintings are still in their early stages, not fully developed. Alan Guth's theory suggests that for intelligent life to emerge and thrive within one of these paintings, it requires a certain amount of time, akin to a masterpiece gradually taking shape. In some paintings, life may be just beginning to take its initial strokes, while in others, it has had more time to evolve and flourish. Now here's the intriguing part. Imagine there's another painting nearby where life is slightly more advanced than in ours, just a small step ahead. According to Guth's theory, the number of paintings with life at our current level is vastly greater than those where civilizations are only slightly more advanced. With the gallery teeming with countless paintings at our level, it becomes highly improbable that we would encounter one where a civilization is only slightly more advanced. Thus, it's quite plausible that our painting hosts one of the most advanced civilizations in this grand cosmic artistry. Guth's idea can be illustrated by this concept of multiple paintings, each housing unique civilizations, adding a fascinating dimension to our comprehension of the universe. It invites us to contemplate the diversity of life and intelligence across this cosmic gallery, leaving us awestruck by the infinite possibilities that lie beyond our own canvas. Now, shifting gears, let's delve into a philosophical argument proposed by Nick Bostrom, a philosopher at Oxford and director of the Future of Humanity Institute. In his paper titled, "Are You Living in a Computer Simulation?" Bostrom presents a compelling argument that at least one of the following three statements must be true. 1. Humans are likely to go extinct before reaching a post-human stage with the ability to create entirely simulated realities. 2. A post-human civilization with the capability to run such simulations would probably choose not to run many simulations. 3. We are currently living in a computer simulation. Using clever logic and mathematical reasoning, Bostrom arrives at a thought-provoking conclusion. Unless we are already existing within a simulation, the belief that we will eventually evolve into post-humans capable of running ancestor simulations is likely incorrect. Now let's explore the concept of how such a simulation could come into existence. Speculations from various writers suggest that an advanced Type 2 or Type 3 civilization might embark on the creation of a colossal computer system known as a Matryoshka brain. This unfathomably massive system would harness the entire energy output of a star, achieved through the construction of a Dyson sphere, a structure that envelops the star to capture all of its energy. Mathematicians have delved into the capabilities of a Matryoshka brain and calculated that it could possess an astounding amount of computational power, enough to generate an entire simulated universe where we, along with countless other beings, could exist unknowingly. Remarkably, this concept doesn't seem to violate any known laws of physics. Instead, it sparks a captivating exploration of the nature of reality, the potential existence of advanced civilizations, and the profound implications of our place within a vast simulated universe. If we entertain the notion that we are indeed living in a simulated universe, created by a highly advanced civilization with a Matryoshka brain, or a similar colossal computational system, then the question of extraterrestrial life takes on a new perspective. In this simulated reality, the beings responsible for creating the simulation could have engineered various scenarios and worlds, including those harboring intelligent life forms like us. These simulated beings, including potential extraterrestrial entities, might be an integral part of the design of this grand cosmic experiment. Furthermore, if the creators of the simulation possess the ability to manipulate the parameters and variables of the simulated universe, they could introduce diverse life forms and civilizations, including those of extraterrestrial origin. As a result, the presence of aliens within this simulated reality becomes a plausible possibility. From our standpoint as simulated beings, the quest for extraterrestrial life takes on intriguing questions. Are other intelligent civilizations we may encounter real entities, living in their separate simulations, or are they, like us, simulated entities? Moreover, if we are part of a simulated universe, the Fermi paradox could be re-evaluated. Perhaps the silence from alien civilizations is a deliberate aspect of the simulation's design, or it could result from limitations imposed by the creators. In the realm of quantum mechanics, the concept of entanglement allows two particles to become instantaneously correlated, regardless of the distance separating them. Superposition, on the other hand, permits quantum particles to exist in multiple states simultaneously. Imagine a scenario where advanced alien civilizations encode their communications and energy emissions using quantum-entangled particles and superposition states. By doing so, they could create encrypted signals that appear as random noise or background radiation to less advanced civilizations. Detection technologies would perceive these signals as indistinguishable from natural phenomena. As a result, it would seem as if these advanced civilizations do not emit any detectable signals or energy signatures, leading us to perceive them as silent or non-existent. In reality, they are actively communicating and functioning within the universe, but their quantum information hiding techniques render them invisible to conventional detection methods. Furthermore, these advanced civilizations might have developed quantum cloaking technologies that make their spacecraft and installations non-transparent to electromagnetic waves, allowing them to move through space undetected. This technological sophistication would make it challenging for us to observe their presence. In contemplating the possibility of extraterrestrial life, it's essential to consider that we might not have found it yet because their technology is so advanced that it blends seamlessly with nature. Perhaps alien life exists in forms we haven't even conceived, such as beings made of energy or dwelling in environments entirely different from our own. Additionally, intelligent life could exist in different dimensions or parallel universes that remain undiscovered to us. It's possible that intelligent life is out there, but it awaits our civilization to reach a specific level of technological advancement before making contact. Alternatively, the vastness of the universe may conceal intelligent life in unexplored regions. These beings might not be interested in contact with us, or they may be observing us without our awareness. Lastly, and on the contrary, it's conceivable that we are the only life form in the universe, a unique and solitary occurrence. After Enrico Fermi famously posed his paradoxical question at Los Alamos, physicist Leo Szilard humorously responded with, "They are among us and they call themselves Hungarians." While humorous, it highlights the vast range of possibilities that the Fermi paradox presents. So, what's your own solution to the Fermi paradox? Feel free to share your thoughts in the comments below. Thanks for watching, and I'll see you in the next one.